Mrs. Moore is here in room 200, and we're getting all set up here. We first have to write in our planners. So before we begin our class, I like to start each class period with a brief prayer. So if you could please join me in saying here this short prayer. And it's in the name of the Father, and of the Son, and the Holy Spirit, amen. Just simply, Jesus bless us and center us this day. Amen. Okay, so I'm gonna stop sharing that with you on the screen and have my kids write in their planner right now our agenda for the day, which is gonna be to cover lesson 2.1. And we're gonna do both sides of that workbook page together. And let's see, what would the page number be for 2.1? It's gonna be 15 and 16. So let's write that on our planner here. Lesson 2.1, workbook 15 and workbook 16. But then something else I'm gonna write in a different color so that it stands out a little bit, maybe in red, because this is in regards to your test, is going to be your test corrections assignment. And that's gonna be due by Friday morning, okay? Test corrections due Friday the 2nd. I'm gonna be handing back your test results to you today. And your online kids should have received an email with your scorecard and instructions on how to correct your test. Okay, so check your email for that. I'm gonna go right on the board. So everyone write test corrections. And when is that due? Due Friday, you got it. Okay, so expect to get through at least the Sadlier content today, and then you will have to work on your test corrections throughout the week. You know, work on it a little bit here and there. And I wanted to take a minute and kind of explain the whole procedure about test corrections. Where did I put that? Oh, here it is. So that you know what to do. And this will be the procedure we follow for the entire year, okay? So when you get your test back, that grade is done. That grade is already in PowerSchool. It's not going to change. But you do have another assignment called Chapter 1 Assessment Corrections, and it's going to be graded separately. It's going to be worth 3 assessment points. What you have to do is look at your test, and any of the items that you got partially wrong or all the way wrong, you need to take a sheet of loose leaf and rework them. You do not have to copy the entire question down. Like if it's a big long story problem, something like that, you don't have to copy the question. Just please write what number that your work is showcasing. Does that make sense? So let's say there was one question on here, I think it was 11, had 11 part A, 11 part B, 11 part C. If you got part A and B right, you don't have to correct those. Just the part that maybe you got incorrect, okay? And you're gonna document any calculations or thinking on that loose leaf. Please don't just put an answer. The point of this assignment is twofold. It's for you to make sense of maybe some misunderstandings, and for me to figure out how to help you through that process. So if I notice that you're doing the same thing wrong, maybe on your corrections assignment, then I need to have an intervention, right? I need to get together with you and try to help you get back on track with that skill. Something that I've developed for all of you, and I've never done this before, is I know that we're really unable to work in small groups, for you to come and sit by my desk for 15 minutes and we'll work through just the time that it is, we aren't able to do that. So what I made was an additional video, and I'm literally performing and going through every single test question And that way, while you're doing your corrections, it's kind of like I'm right there with you. If you had a question on number 3, then fast forward to spot number 3 on the video, and I'll help you through it, okay? I'll help you understand it. Do you think that that would be a valuable resource for you? Okay, what if you've used the video for your corrections, but you're still stumped? Then what should you do on number 10? If you're still stumped, what should you do? And you too, in the waiting room here, type in what should you do if you're still stumped after watching my video. What do you think? You could try asking a parent, but I'll tell you what, come 6th grade math, parents are like, nope, we're done with this. It's algebra. I don't want to look. So give it a try. But if there's no one in your house that can help, we still have to solve the problem. What else can you do, Katerina? Sure. Yeah, maybe put a question mark next to it, give it an attempt, and then bring it to me. I'm here at 7:30 every day. Pop in and come in, see me. Maybe we can work through that together in the time that we have. Of course, in a distance way. All right. So what we're going to be doing, you could also send me an email. I hear some people type me that. You can try using your textbook. I know we don't use it much in the classroom because mostly what I'm saying out loud is from the textbook, and we don't need to go in 2 different spots at the same time, okay? So when I give you your test back to you, it's no one's business what you got, right? You can go put it on the fridge at home, but you cannot announce to the people near you what you got wrong, what letter you got. That's inappropriate, okay? You can look at it briefly, but then you have to put it away so that you can work on the corrections on your own. Use the video if you need to, and you're welcome for making the video. If you got a D or an F, you must have it signed by a parent. If you got a 100% A, then you have no corrections at all. You got a 3 out of 3 on that assignment. Good? Yes. If it's a valuable tool, I would love to do that. Shane asked if I would make a corrections video for every test we have. If I find that it has 5 views, it might not be worth my time. If I see that it has like 35 views, then I know enough people are utilizing that resource to make it worth my time, okay? So if I don't make a video, Shane, then maybe if there's a question or 2 that you need help on specifically, then you and I can meet, or we can hop on Zoom in the evening sometime for 10 minutes or something, okay? All right, I'm gonna walk around the classroom. Good idea, Paige, use your notebook. We're gonna be able to use our resource notebook for assessments usually, but definitely use them for your corrections as well. I'm gonna go pass these out, so I'll be back in a minute. What you need next is gonna be your resource notebook, open to the place value chart that we had put in there a couple of weeks ago, and your workbook, and that just needs to be on standby for now. If you are here in the classroom with me, if you have like a little dry erase board in your desk, do you have that? No? Okay, never mind then. We'll just do it on the board. Oh, here, I'll put it over there for you. Natalie's. You guys all switch seats on me. It's hard to find. It's hard to find you. There you go. Anyone absent today in this class? Just Lucy? All right, we're getting close here. There you go, Nicholas. Did everyone get theirs? Yes? Got it? Okay, good. Didn't have any sorting malfunctions. Okay. I'm gonna get my Promethean board turned on here. And we're looking at the place value chart. So my online kids, if you can show me a thumbs up if you noticed in your email inbox, if you received the chapter 1 assessment results, okay? That way I know that you'll be able to complete those for me by Friday. Check out my video, okay? But we're gonna start instruction today on chapter 2. Now, I want you to know that we're not going to have a chapter 2 only test. Chapter 3 is so closely related, I'm gonna wait and bundle them together. Chapter 2 is all about multiplication expressions and evaluating, and chapter 3 is all about division. So we're just gonna bundle them up. Since we did addition and subtraction together, we're gonna do multiplication and division together. Good? So what we're gonna be working on over the next couple of days is getting comfortable with the place value chart and what powers of 10 mean, and what kind of patterns they generate in the number system. So I wanted you to take a look at this first example, and this is nothing that is in your workbook, but we're going to be using your place value chart to kind of help us out, okay? So I have a pattern of numbers that I'm going to write down. And what do you notice about the different sequences that I'm writing down here? What are you noticing? What are you noticing, Shane? Oh, I like how you even told me a direction. He said that every line here is going kind of down in a place value. It's getting smaller and smaller and smaller. So if you look at your place value chart, if this is the decimal point and the ones place, right? We're talking mostly about the decimal zone that goes infinitely that way. The positive whole number zone goes infinitely that way, and there are like mirror images of each other, right? So if this ones place was kind of the center fold of our number system, we have, and it's hard to see with the mask on, tens, tenths, hundreds, hundredths, thousands, thousandths. And the only difference in the language of the ones on this side is those decimal zones have a THS on the back, right? But they're exactly the same wording on the left as they are on the right. The ones that are on this side get 10 times bigger every spot that you hop, right? 10 times bigger, but these get 10 times smaller every place value you hop, right? So you can say 10 times smaller, or you can say divided by 10. Something getting 10 times smaller is the same as saying divided by 10. Did you know that? Why? Because multiplication and division are opposites of each other and they complement each other. So I was trying to explain this to another class today, is that you might have had all these building blocks throughout the years where you're learning about fractions and you're learning about decimals and you're learning about place value. But sixth grade is the year where we kind of combine all of that knowledge and be able to toggle back and forth between each of those knowledge groups, okay? So if I were to replace these numbers, these decimal numbers, 0.1, 0.01, 0.001, 0.0001, with fractional values, what fraction would represent 0.1? And if you don't remember, this is where you look on your place value chart. Look on 0.1, what fraction is equivalent to 0.1? Class? 1/10. Okay, so let me just erase that real briefly. And I'm gonna go and put in the fractional values. What was the next one gonna be? 0.01. What's the fraction that matches that one? 1/100. And then what's the next one? 1/1000. And then the next one? 1/10,000, right? So you're starting to understand what the relationship between a decimal system and a fractional system is. One more thing. Now look at the powers of 10 that are on your place value chart. What power of 10 is associated with 1/10 or 0.1? What power of 10, Isaac? To the -1 power, yeah. So 10 to the -1 power, you can see that 10 with a little exponent of a -1, meaning take that 22 and move them one place value over to the right, into a smaller zone. What if I moved it 2 place values to the right? It's the same as saying 2 hops in the place value zone, right? What would this next part of the sequence be? 10 to the -3 or -3, and then 10 to the -4. And this is exactly the same as what we were showing before in decimal form, fraction form. What form is this? Powers of 10 form, okay? I'm gonna do this again. Where's my erase button? She doesn't have an erase button. This one? Oh, her pen, no, I wanted to erase all of it. That's what I wanted to do. But mine has a different button on, it has like a recycle button, and it kind of makes it new again. Anyway, I'm gonna put another sequence of numbers up here. 54.7, and I'm just gonna keep that same number. And I want you to tell me now what happens with it, okay? So we've practiced showing different formats of the same number, but let's talk about what the results are going to be. What are the results going to be? What's equivalent to this expression? So if I have 54.7 and I pick it up and I move it one place value to the right and plop it down, where would it land? Where would it be? Where would that decimal point land? It would still be a 5, a 4, and a 7, right? But I'm picking up those numbers and shifting them one spot over. Could you write maybe on, what do you have open here? Your place value chart? Imagine the 5 and the 4 in the 10s in the 1 spot. Imagine the 7 in the 10th spot. Imagine picking them up and scooching them down one slot. Where would it be? So tell me the result of that number. 5.47. Is that what you got? What if you took 54.7 and you slid it 2 place values over? Where would it be? Say it out loud. 0.547. Are you getting the pattern here? What if you slid it 3 place values over? Where would it be? Exactly. Okay, so we're starting to establish some strength with recognizing patterns in our decimal system here. I'm gonna do one more for you. It's gonna be a little bit different because I'm gonna write them instead of using decimal values, I'm gonna use fractional values, okay? Times 1/10 times 100th times 1,000th. Okay? So talk to me. What's the result of this first line going to be? If I slide them one place value over, what do I got? 1 and 32 hundredths. Okay? If you're on Zoom and feeling like unmuting, I'm the only one can hear you. I've got AirPods in. Okay? So, I mean, your online class can hear you, but none of these kids can hear you. So go ahead for this next one. What would 13.2 times 100th be? 0.132. How about 13.2 times 1,000th? 0.0132. Okay. Different? How about one more with just powers of 10? Okay. Okay. What if I took that 30? He's in the 10s and the 1s, and I split them over one place value. Where does it land, class? It would be 3, right? The 3 would be in the 1s place now, and if you'd like to write it, the 0 would be in the 10th spot now. Is 3 the same as 3.0? Yes. Why? Does this 0 carry any value? It does not carry any value. So I could infinitely put this many zeros on the back and it would not change the value of that 3 in the 1's place. What about this one, 30 times negative 2? I'd have to slide it one place value deeper so it goes into the 10th spot. I could put zeros infinitely on the back as well, but they don't carry any value. So you can just leave it at that. Next one, 30 to the negative 3, 0.03, right? And does this 0 carry value though? What do you think? Yes, I'm hearing yes, 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 yes from the online people too. Good job.
Yes.
It does. Because although a 0 is nothing by itself, it's structuring the number so that 3 can carry the value it's supposed to. If you just got rid of that 0, the 3 would have gone into the 10th spot, and that's not what we wanted, right? Zeros that are in between the decimal and a digit carry structural value, okay? So those are important. Do these zeros on the end carry any value? No, right? All right. Now, I think we're ready to get into our workbook. So we're going to open to 15 right now. Everyone open up to 15. We're doing okay here. We're doing okay. And I'm hoping that's large enough on the board for my online crew. Is that large enough for you to read what I have there? Can someone answer me?
Yes.
Yes. Yes.
Okay, great. So I'm just going to annotate over the top of this. Go grab your note, go grab it. And we're just going to pick up on some of the patterns that we just demonstrated, okay? So how about for set number 1, if you have 98.6 and you're sliding it one place value over to the right, what happens to that 98.6? It becomes 9.86, okay? All right, take the next place value. What does that 98.6 become after 2 hops? What does it become, Shane? 0.986. So the digits stay the same. The 9, the 8, the 6 still stay in their same arrangement. They just get slid down the line a little bit. Good? What would I do for this one? Erin, what do you got?
The camera's off.
Well done. Yep, 0.0986. And I'm seeing some people privately send me the answer here in the Google Classroom. Nice job. All right, so that's number 1. Take a look at number 2 and see if you can do number 2 and 3. No, just 2. Just do 2. 3 is a little different. Go ahead, do number 2 on your own. Where is the decimal as it stands right now? There isn't a decimal written there, but where is it? Where is it located? Where is that decimal located? After the 6. Okay, so you can put it there if it makes you feel better about sliding it, place values, okay? So do all of set 2 for me. Go for it. Nice job, everyone. Okay, so I'm seeing some answers come in now. We've got 74.6, 7.46, 0.746. Easy. Now look at number 3. The original number is different each time. So careful that you are moving it the appropriate amount of places, okay? 12, 1 slide over becomes what? 1.2. But 120, 2 slides over becomes what? Go ahead, Parker. 1.2, yep. And 1,200, 3 slides over becomes what? 1.2, yeah. So you can see that there's a relationship between the number of zeros that are on the back of a number and the number of slides that you're taking it that help it end up with a common result. Could you do me a favor and just as a little challenge?
It's more.
Yes?
I can't really see like a little part of the other board, like a little bit of the other part of the board.
So, is that good?
Yes.
Okay. Could you do me a favor? And what would the next line of this sequence be? So if we built up this term and built up that term, what would the next expression in this sequence be? You know what I'm asking you to do is follow the pattern. What would the next sequence line be here? What do you think? Go ahead, Evan. 12,000. Yeah, and it would still be, what's the result going to be? It's still going to be 1.2. He said, and I'm going to type it in here so that you guys can see it a little bit more clearly. He said 12,000 times 0.0001, and it would still be equal to 1.2. Because the number of zeros here offsets the number of zeros here, and it's kind of like they eliminate each other and cancel each other out. Good? All right. Numbers 4 through 9. Work on them independently right now. Go ahead, 4 through 9, and I'll pop the answers up in just a moment. 4 through 9. Do 4 through 9. You're going to take this value. It's based on, well, what is the equivalent of this number here? Well, what spot is that one in? In the hundredths. So you're moving into the hundredth spot. So how many spots are you moving that 5? That 5 is getting shifted 2 place values. Hundredths is different than 100, right? Multiplying times a fraction is different than multiplying times a whole number. It's the complete opposite, right? Okay, just taking a peek here at number 4. This is your directions on how many place values are you sliding that 5? Are you going into the smaller zone or into the bigger zone, class? Smaller zone because it's a decimal. How many place values are you moving? 2. So pick up the 5 and move him 2 spots. What do you end up getting? 0.05. Okay, that 5, and then you can check moving back and forth. If I move him back, boop, boop, is he where he started? Yep. Mm-hmm. No, you just put a 0 in that little scoop. Mm-hmm. So that's right. That's what you have. Try another one. Try the one that has numbers already built into it. I bet you it'll be easier. Slide it twice for this one. Mm-hmm. So slide it twice. The decimal goes right there where your point ended. Mm-hmm. I'm just going to pop a couple answers up here so you guys can check. How's this? Do you have 9 done? John, I'm going to come look at your paper. Okay. Oh boy. What's number 8? How many place value bumps are we going this time? 1, 2, 3, 4. So I only have 3 digits to give. So I have to make sure I have the right amount of spaces that I'm moving at, right? Is this correct? Let's see. Make sure I can move it back. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And then this guy, 1, 2, 3. 1, 2, 3. Do I have to put the 0 on the back of that one? No, he doesn't carry any value, but you can if you'd like to. So for numbers 10 through 15, they've given you some part of the multiplication equation, but you need to figure out which part is missing. Is it the digits or is it the position? So for number 10, notice how the position is already written. You need to give me the digits that this number started with. So can you see where it ended and then kind of work backwards to figure out where it started? You would just move it forward 2 spots. right? Instead of backwards, we're gonna move it forward 2 spots. So if I moved this one forward 2 spots, would it get bigger or smaller? It would get bigger, right? So we have to move this 2 place values bigger. What would that number have started with here?
3,250.
3,250. Good. Again, number 11 says, here is the position that was applied. Pick up that number and slide it 2 place values over. Where does it sit? Where does it land in? Oh, can you answer that first? I said, can you answer this first before you go? If you move this 2 positions over, where would it land? Yep, so we're kind of going backwards, right? Because we're trying to figure out where it was to make it land there. So we're working backwards. We're going to pull it back where it was to start. So how many would 2 place values bigger be for that number? What do you think? Imagine picking up that 0.9909 and scooching it 2 place values over. So this would be 1 place value over, and then one more hop would be 2 place values over, right? So we've got 99.09 for that one. Okay. How about number 12? We have to move that 60 2 place values over. Boop, boop. So where does it land? Where does it land? 600? I can't really hear you. 6,000? Okay. Because we're making it 2 place values bigger than where it landed. If you go this way, Nicholas, beep, beep, would it land where it's supposed to? Okay. How about these bottom ones? They give you the digits, but they don't give you the position. So we need the directions on how many spots did I move. So I'm looking and comparing the decimals in these 2 numbers. I see the decimal here and the decimal here. The number's getting smaller, so I know I need to use a decimal or a fraction to describe what happened. But how many hops did it take when I moved it? Was it just 1 hop? Yes? No? How many hops? How many slots? 1, 2. I'm seeing one fingers up here. 1 slot over. So if it only moved 1 slot over, then I just give it a shove with 1 place value. That would be moving 1/10. How about this one? How many place values did this one move? How many place values did it move? I'm seeing 3 fingers here. Yeah, 3. So I have to do 3 place values. There's 1, there's 2, there's 3 place values. Could you also write times 10 to the -3? You could write that. Could you also write 1 over 1,000? You can. Natalie, what do you think? You gonna answer the next one for me? Okay. All right, nice. All right, I'm not gonna have time for number 16 today, but I think the backside is something you can manage now that we've explored like this powers of 10, fractions, decimals relationship. So page 16 is gonna be for your homework, all right? And I want you to get out your planner right now and highlight 15. Highlight 15. And then this is what you're going to be doing for homework, okay? Yeah, you could do it during extra gym if you'd like. Our kids here in the class have an extra gym so that your teachers can have some online prep time so they can better serve you guys on the home front here, okay? So take a look at today's lesson. Attempt every problem, you know the drill. And if you have any further questions, you can ask me before school. You can come on to my Zoom office hours. Mrs. Doherty, I believe, has her Zoom office hours scheduled a couple times this week with the 6th graders. Actually, I think it might be today is one of them. Go ahead, Natalie, what's your question? Oh, you're using the bathroom? Okay. Planners all situated, everyone? Okay. I will see you all next time, and this is going to be downloaded and recorded. Gavin, I saw yours kept coming on and off. I don't know if you're having some internet trouble today, but this whole session's been recorded, so you can rewatch it as soon as I get it loaded into the Google Classroom if you need to, okay? I don't know if he's even on here right now. I don't see his name. If anyone talks to Gavin, let him know. Do you guys have a better time hearing me today?
Yeah.
You can see better in this room. It's hard to figure out which room works best for videoing.
Yes.
Kind of changes each day based on what we're doing, but this seemed to work well today. We all good? All right, I am out of here. See you guys. Let's say bye to everyone.
Bye. Bye.
Bye.